Hello, everyone. Welcome to this webinar to join Huawei to show our understanding and also have a discussion on how do we build the future-oriented access network. And a brief introduction of myself. I worked on the fixed access domain in the past 20 years. And so that is also the 20 years of the development of a broadband access technology and the network. So it was also my pleasure to share my understanding to the future development of the fixed broadband world. So actually, when we see the development of the future access network, so let's still have a little bit look back on the history of broadband on the fixed network in the past. We always discussed a lot on the generations development of wireless worldwide. So we have 3G, 4G, and 5G. Actually, in the history of a fixed broadband, it is also there is a clear generations of different technologies, services, and the network architecture on the fixed broadband world. So which could be clarified also in the 5 generations in the past. So we will have an overview for that at the beginning. Let's say in last century, it is still the first generation of the fixed network. The major services, mainly the voice, and based on the PSTN and POS technology. So with twisted pairs access, with the narrowband access. At that time, the services is mainly on the voice, but there's still a little bit text-relevant services. For instance, that at that time there's still also the narrowband dial-up services. Internet started. It's very straightforward and lasted for long times, for decades and even 100 years of that. And things that times goes into this century, and the broadband is starting to be introduced into the fixed access technology. So still based on the twisted pair, we have ADSL at the beginning of this century. And that increased the bandwidth from kilobits to megabits level. And so ADSL will support from 2 to 10, even 20 megabits per second services. And there is more services will be introduced. Internet was developed at that time, and email and web browsing and very low density video is also was also appeared at the time. So that would be the second generation. And afterwards, that the bandwidth is limited, and so we got a generation of third one, which is represented on the fiber extension and the shorten of the copper loop. So we got the different technologies on the twisted pairs, and in that generation, there are multiple options of them. And there was VDSL, there was VDSL2, there was a vectoring, there was a vectoring, a super vectoring, etc. Based on the network architecture of fiber to the curb. And so the fiber or fiber to the node, and the copper line will be shortened into hundreds of meters to reach higher bandwidth and tens of a megabits level. So at that time, so the video services entered from the standard definition to relatively high definition area. And so the internet is also explored all over the world along with the mobile broadband. So actually the mobile broadband is introduced in the world along with the 3 generation of the fixed one. So that time lasted for around 5 years. And when time goes into around 2015, we got the 4th generation. And the typical technology is a fiber to the home, the end-to-end fiber to the home with GPON access to the home. So at that one, the service packages to the normal residential broadband will be increased to hundreds of megabits level. And the ultra high definition, 4K ultra high definition video is started to be introduced. And so there's more and more services and more and social communication, and also even the video communication is also introduced with this generation of the technology. Most important one, we will get an end-to-end fiber to the home infrastructure in the ground. And so this period of time lasts also for the next 3 to 5 years. And at this time, we have an opportunity to start to develop to deploy the fifth generation for fixed gen network. So that is FG5. There is more features will be introduced. Firstly, the bandwidth is introduced another 10 times higher. And so the technology are moving from the GPON to 10 GPON, bringing gigabits level service packages to residential broadband. With this higher bandwidth, there are more services on residential broadband. Let's say the virtual reality, augmented reality will be considered by a lot of operators and also the internet world. And that's one thing. It's another one that there's more connections will be introduced also with the fiber connection. In the past, that the fiber technology or broadband access are mainly connected to the residential subscribers. But in this generation, there's more and more devices, there's more and more kinds of customers will be introduced. There are some of them, for instance, the camera, ultra high definition camera will be introduced into this one. And business buildings and all business campuses will be connected with fiber or even covered with fiber internally. And the industrial manufacturer factories and also the ports, the airport, the hotels, and city surveillance systems will all be connected to fiber. Even inside home, and that the fiber will also be extended from the entrance of the home to each of the room of the home to bring the end-to-end 1 gigabit service packages. So with this one, that the automated user experiences also required to support this extension of the fiber world will require higher bandwidth, will require lower latency to some kind of very strict business applications and automatic manufacturing. And we will also support the higher reliability, since that the more and more high value subscribers will be connected with the fiber. So there is a different generation. In the past, the bandwidth bring a better life to us. But now, the gigabit fiber world will change the society from the previous smart society to a smart one. So that's the first thing I'd like to say. And from our observation, there is a rough statistics that till now, there are already over 240 operators in nearly 50 countries has a commercial launched gigabit services. And there is also even 10 gigabit services to residential broadband launched by operators globally. And there is also more and more operators are joining this world. And just in my country, in China, and that all the three biggest operators are constructing the gigabit network with a fiber to the home very actively. And actually, there is over 2/3 of the premises of China has also the commercial launched gigabit services. And there are also the statistics that till now, the service packages over 500 megabits per second has already surpasses 15 million subscribers, and over 500,000 really 1 gigabit services is already connected into this world. So there is explore the next generation broadband access technology and with a fiber access one. And so what is the drivers for that? And so bandwidth increase is just definitely one of the most important one. But furthermore, the operators are concerning and the service experiences more and more, since that bandwidth, when bandwidth has reached to that high level, gigabit level, it is not the bottleneck anymore. But there is still a bottleneck to guarantee the end-to-end service experiences to the residential broadband and other services connected to with the fibers. For instance, that ultra high definition video, virtual reality, which is considered of the next generation IPTV, and the gaming services. They are all considered as a high value services or applications to residential broadband. And so that will be required the capability of the network to be increased to another level. from the core part, from the access network part, from the home network part. We know that these services are very sensitive to the bandwidth, to the latency. And just as one example, the virtual reality, we know that an operatable level virtual reality asking for the service packages bandwidth over 150 megabits for one stream. If we consider that in one residential home, there should be 2 or 3 virtual reality glasses. So 500 megabits or even gigabits is not something too high bandwidth to support this services of the operator. And furthermore, the end-to-end latency of the operationable virtual reality should be controlled to 10 milliseconds from the glasses to the cloud. So that is also a very strict and service level requirements to the network. So we have to build or update, optimize our network somehow to support the new future services. But till now, there is still difficulties to construct this gigabit-oriented network. There are several of them. One, we have still an existing network in our network in all over the world, and there is different generations of the network still existing according to the different territory, different countries, and different operators and different bandwidth requirements. Now there is still the existing ADSL, so which means that second generation, the fiber to the node network, the third generation, and also the fiber to the home. So we have to consider how do we migrate all this existing architecture into the future gigabit-oriented network in a smart way, in an economical way. So that comes to the construction of the physical fiber network, the ODN network. It seems to be the biggest obstacle to construct the end-to-end gigabit services. We listed some of the typical levels that we analyzed in different countries, in Europe, in Africa, and also in Asia area. In some countries, it is still quite expensive. So that will break the business case of the end-to-end fiber to the home application and network construction. And the third one is the user experiences. And so that will be also to two aspects. Firstly is the user as the broadband consumer. We are asking the operators to provide them with the guaranteed really bandwidth services. It's not just the peak, but it is also means the service quality to the not just the speed, but also for the services applications they're using and their video services, their gaming services, etc. And the second aspect is to guarantee that the automatic or easy maintenance operation of the broadband network of the technicians. We have also some of the typical services numbers here. For instance, in Europe, the acquisition cost for single subscribers is around $350. But so it is a very high cost. So we got these subscribers. There should be the way to guarantee that it is not easy to transfer the network to the others. We need to guarantee that network quality, the services quality we provided is attractive to them. So this is the opportunity and difficulties for that. And so before to share our understanding on the next generation technologies and network architecture, I'd like to get a survey for the audience on what do you think about the most important things of the next generation network. So I will hand over the time to Abby for this survey.
Hello, everybody. The question is, which do you consider as the top tech priorities for next generation fiber access networks? First, smooth migration from GPON to XGPON and XGS-PON The second is economic and fast audio installation. The third is Wi-Fi 6 and home networking. The fourth is multiple services with optical fiber. The last one is automation of network O&M. Let's have a look to the result. Xiong, could you please have any comments for this result?
Yeah, it seems that all of the 5 options will got the significant support. So which means that actually the construction of the next generation fiber access network is not some simple target. So should be an overall consideration to all the different aspects, including the network construction, the services, and the passive part, the active part, the home network, and also the operation of the network. But still, we found that the network construction, including the migration from the existing technology to the future one, and the network construction to the network part and of the home network is still most concerned. Okay, so that will be very interesting and effective poll result. So with that, I think that will be also very good import to the following session that I'd like to raise. And so it is also to show our understanding and to the physical network architecture and also the end-to-end solutions to the Gigabit Ful-Fiber network. As I mentioned, it is a physical network to cover different kind of services. And we emphasize not just the fiber to the home, but actually to everything. And we listed here to business campuses, to offices, and to desk, to different office area, and also we listed here fiber too, as I mentioned, the fiber extension inside an apartments or big building. The fiber will be extended to the machine in the factories for automatic manufacturing, and also probably to the mobile site. So that will bring us a new blue ocean to the fiber world, since that the physical fiber infrastructure is not just to home broadband, it is the city facilities to any kinds of digital application in future. Okay, so with this extension of the fiber world, we need to increase or improve the capabilities of all end-to-end physical access components, including the OLT at the head end in the central offices, and the high efficient way to construct the ODN, passive part, and to improve the capability of the home network with the powerful ONT and home coverage solution. We'd like to also to increase the experiences with the operation of the operators. So the intelligent way and automatic artificial intelligence way will be introduced to manage the network, to operate the network, to diagnose any faults, and to introduce the some kind of a proactive maintenance method to guarantee that network is in healthy status. So I'd like to also to expand these arguments somehow in the following slides. Firstly, a new ocean with new opportunities. We mentioned that the video services or residential broadband services, virtual reality and gaming at the beginning on the inside part. I'd like to raise some other cases for the extension of the application. For instance, for the surveillance. We know that the city surveillance or any industrial application for the camera backcoding is getting more and more important. But there is still a change in this industry. And so the camera is also moving from the standard resolution components into the ultra high definition, 4K, and to the bi-direction image, especially for the uploading. So that will ask for the uploading traffic to be increased compared with existing technologies. And furthermore, that with the surveillance algorithm, there is also the artificial intelligence needed for the human face recognition, for any kinds of so traffic management, for the car label recognition. There is also the computing equipment will be in the network, in the cloud, and also somehow distributed into this one. So asking for not just the bandwidth, but also for the latency, for the distribution of the computing capability. Another example, for instance, for the smart manufacturing, we also got some of this practice even in our factories of Huawei. Just to give them an example, trying to build the OLT LAN cards in our product line. We are introducing the kind of 3D dimension image, automatic image to test the manufacturing quality of the products. Just one single LAN card, when we get such kind of complete 3D image built, just single LAN card will generate an image of around 7 to 8 gigabytes. So that will need the real-time transportation through the product, through the manufacturing line, and also the management cloud. So that will ask also for the upgrading of this existing network. And there is also a lot of similarity to the other part, for instance, for business campus, etc., etc. So there is a more abundant services introduced in the network, so the network quality also be needed. So that will be one thing. And then comes to the network capability. And to support this kind of multiple services with a single optical-oriented physical access network, so the network capability could be deployed in a single physical network one, but with difficult logical slicing. That could be very similar to the slicing mechanism of the 5G solutions, for instance. Just as one examples here, and there is two typical services: residential broadband and also for the enterprises. The enterprise access with the fiber access is somehow to be considered as a kind of a low-hanging fruit of this, the expensive optical-oriented network. But these services ask for totally different quality of the network, total service guarantee, to different different operation systems, and also different management OEM teams for the operators. So there is multiple slicing will be needed to support multiple services of them. And we list just the two, but actually we also have listed the multiple services at the previous discussion. There is more and more in network or services needed to be supported as well. So we need to support more powerful slicing capabilities. And so to guarantee that they could be managed in different quality and different SLA mechanism. So for one thing, on the network architecture to support multiple services. And the second topic will be the migration, smooth migration from the existing generation GPON into the 10G PON, XG or XGS PON in future. It is also somehow a highly concerned topic during our poll. No, so the consideration from this one is a kind of to introduce the flexibility of this migration, and to avoid the difficulties of any network construction on the choice of each of them. So with the technical perspective, and so the OLT platform or even the LAN cards should be designed as a single one. So supporting the multiple generations or multiple options of the future PON or 10G PON technologies. So the OLT platform, the LAN cards are all the same, but the difference will be left just on the optical module. So with the same boxes or same LAN cards, and just when you choose the different optical module of GPON or 10G PON, that the different technology will be enabled by this same products or same box. And it is also possible to move from the existing one from GPON to any kinds of 10G PON, Or it is possible to support both GPON and 10G-PON technology on the same single fiber with the same optical module. So there's multiple options for different network construction strategy. And first of all, we all know that the optical power budget is quite essential to guarantee the network quality, to guarantee the coverage of the network. So the latest generation of optical module, the class D, which means that the 35 dB, which is nearly 4 times higher on the transmission power budget and 5 times more sensitive on the receiving side, will be introduced also during the migration approach. So which means that with that one, we will get the longer distance, the more reliable capability on the connections, and more power saving on the RT construction. So that's on the central office part. And if it goes from the central office to extend the fiber to the end consumer, there is a lot expense on the civil work or on the ODM devices somehow with the traditional way, which means that with the traditional splitting technology, with the traditional fusing technology. So to avoid these difficulties, now the industry are going to introduce the so-called pre-connection ODM network construction technologies. By this one, that during the installation of the fiber, passive fiber network, you don't need to bring the fusing machines. So which means just a plug of optical connector and turn it so the fiber is connected. So in the past, we have to do the installation of the fibers segmented by segmented in a sequential way. But with the new pre-connection connected technology and the end-to-end architecture, we may set multiple engineers to install the connected boxes and the connection fibers parallelly. So the installation efficiency could also be increased very fast. And that will be also got the savings for the core connections from the multiple core into a single core one to set up a chain-like topology and to avoid the complicated tree topology. So that's for the on the ODM network construction. And with the connected fibers, then we need to cover the gigabits into the home. So we got the new upgrading for the home equipments. Also on the two aspects. Firstly, definitely the 10G-PON technologies on the network side. But on the user side, the Wi-Fi is getting the most importance to the fiber connection. So the latest generation technologies to support the gigabit coverage inside the home, the Wi-Fi 5 is gradually to be upgraded into Wi-Fi 6. That we will welcome the commercial Wi-Fi 6 application, I think, starting from this year. And in the next year, both on the network side, the Wi-Fi AP and a lot of Wi-Fi stations will all support Wi-Fi 6. So that will be a new generation technology to support the end-to-end gigabit coverage. Also on the wireline or from the wireline to wireless technologies. And based on the abundant speed and that the end application experiences or the management and the operation inside the network is also needed to be increased somehow. So on the Wi-Fi technologies, there will be dedicated channels or dedicated mechanism to guarantee not just the connection speed, but also to the specific services, high-value services. For instance, to allocate dedicated channels, to allocate dedicated and even the CPU resources, cores in the CPUs of the home network to support the dedicated processing for VR or gaming traffic. And the home network is also considered as a part of the extension of the fiber network and will be managed by the centralized cloud, managed cloud with the intelligent way. So that extension on the capability of the fiber of the fiber home. And from the service experiences, we need to raise just one single point is on the automatic maintenance and operation of the network, since that will be highly concerned by our operator colleagues. It is also based on the centralized cloud, but in two working flows. Firstly is the data collection. So the centralized cloud will collect the data and working data, the real-time working data in the network, and to do the generic analysis. So that will be the intelligence or analytic working flow. And with the analyze the result, and that will generate automatic operation or execution according to different services capability and different user behavior. And that will be an automatic execution working flow. So with this cycle, that the network will be managed by the centralized cloud automatically, since that it's all based on the artificial intelligence engine inside the network cloud. And what is our practice? We work with the operators in China on typically two most important headaches for the operators. Firstly is on the management of Wi-Fi interfaces or Wi-Fi signals. Since then, we know that it is still quite difficult to manage the different Wi-Fi channels or to avoid differences inside the completed home air interfaces applications. So all the Wi-Fi signals information will also collected at the centralized cloud, and things that it could do and centralize the calculation for different channels capability, and to allocate just the right channel according to the existing signal and noise situation for specific subscribers. That's for one thing. And another thing is to use the automatic artificial intelligence based way to manage the dummy components, which means that the ODM connections. And then we got the information collected on the active components, but it's still close relevant to the passive network connection and the quality. So with this generated data, that the connections change on the passive part could also be recognized by the intelligent, and to set up the indications for the technicians to do any diagnostic or operation execution or work on the ODM part. And so just one case, we work with China Mobile in Beijing, and in the past they have also very huge, let's say, the complaints on their network, including the passive ODM network and also the home network. But so we work with them to use their fault or complaints data to train our system. And since times goes on, that now they got more and more high efficient, and so diagnostic and operation work improved. 30% of the home visits and also the multiple work, a lot of huge working load on the passive network operation is saved. So that's from the part of that. And as an integrated to all what we mentioned as features, key features for the 5th generation of the fixed network, we'd like to show the case of the Shanghai Telecom. Shanghai Telecom is also upgrading their network from 100 to 200 and even 1 giga. So now most of their subscribers has already got their service packages over 200 megabits. So even with a very fierce competition from the other operators, Shanghai Telecom grasped the leading position of the market very tightly. And so the increase the speed on purpose is also one of the reasons, is that to avoid the decrease of the ARPU since from the competition. So with the increased speed, they may keep the ARPU unchanged, or even to introduce the value-added services and definition video typically to increase the ARPU. So that's for residential one. And second one is that they also use the Gigabit fiber-oriented network, fiber network, to connect it to business buildings, business campuses. So they introduce the business gateways also with the GPON, with the 10 GPON technologies, and upgrade a lot of business buildings, shopping malls with the 10 gigabit services, and to get the more these high-value VIP subscribers with even higher ARPU, 10 times higher than the residential broadband. And to support these multiple services, they also get the slicing that we mentioned. They will get the 3 types of the typical slices in one physical network for residential broadband, for business campuses, and some of the for the mobile application. And so with these activities, let's say the first fully covered 1 gigabit city in China. So that will be also set up in very good, pioneer or examples in all the other provinces. And the operators, all the 3 operators are actually also trying to do this way, to set up and the gigabit-oriented network. Okay, and as the summary from the technical migration for the gigabit-oriented Ful-Fiber network, we mentioned several of the points. Firstly, the flexibility Flex-PON to support the migration from GPON, existing GPON to future 10G PON, and to avoid the difficulties to choose different technologies and waste of the investment. The secondly, 10G PON and Wi-Fi Plus, and also the smart Wi-Fi management inside home to guarantee that the gigabit service is not just connected to the entrance of the home, but could be extended also inside the home. And third one, and that the passive network is also going from the previous fusing technology to the pre-connected based technologies to simplify the installation, to improve the installation efficiency and control the cost of the passive part. And above all of the active and passive connections from central office to the home will all be managed by an intelligent engine with the technology behind it as artificial intelligence and machine learning. So I'd like to close my presentation. And typically still, a gigabit-oriented broadband network, not just for broadband, that will be the next generation and the core part of the generation extended in the next world. But the fundamental technology behind that is G10G PON Wi-Fi 6, and to bring us more opportunities to connect different kind of services and subscribers into this end fiber network. Okay, so that's all for my presentation.
Thank you, everybody. That's all for today's webinar, and looking forward for next time. Goodbye.